All right, now for the last one. This is that last page of actually putting numbers in to feel, the force of a wire that's carrying electric charge or the force of a particle. How do we calculate those? That's what this idea was here. The first one is that the proton isn't moving in this case, and it's in a field. So if the proton isn't moving, magnetic fields don't interact with charged particles. They interact with moving charged particles. So that was the trick question, but I gave you all the information you might have thought you were going to create and calculate, but that's what that ends up being. Let's take this guy out of here. Let me go down to one. That's this number 5 one, and the rest I think you can do once you've seen me do a couple of these. That I want to work on that problem here, and if you can do that one, I think the rest are great practice, and they should make sense for you from here. You got a field that's going to be generated around A and B. B is coming out towards you like this, and so the field is going to be curving this way. So if I draw the field in this one, I'm going to start right in here. Okay, that direction is 1, and then the next one showing, yeah, it's still a strong field here. Then as it gets out, it's going to get a little weaker by being a little further away, and then finally way out here, it's going to be quite a bit. Now, that's the field that's going on. So sketch the direction of the magnetic field by B in the neighborhood of A. That's in here. Will the wires experience attractive or repulsive force? Well, here's where you have to use your right-hand rule. Now, you point your fingers where the force is, right hand. You put your thumb, how can I do this? Okay, you put your thumb where the current is going into the board. Here's where the force is going, and my palm is showing where the push is. My palm is pointing out this direction. So, you should be able to answer that. That is a repulsive force because of the right-hand rule. Okay. This one's great. It says, what factor will that force feel on wire A if the current here is doubled? That current is doubled. Sorry, if the current in B is doubled. So what we need is the formula for the current to force ratio. So the force on any, based on some magnetic field on a wire is going to be related to the current, that's what I is, times the length of that conductor that's in the field, times the field itself, okay, the strength of the field itself. So, that's the force. There is a formula for what the strength of the field is for anything, and the strength of the field is given by some constant, depending on what the material is. That's what's called. It's like air has a value and wood has a value. Those kinds of things. The current, and then divided by 2 pi r. Okay, so if you double the current, that's going to double this, or triple the current, that's going to triple your field. But if you change the distance from r, like you double the distance r, that's going to make half the value. So you don't have to calculate these, but you do have to reason them. So when we come back here and I say, if I doubled the current going through, if I doubled this I, that means I would double the value of B. Okay, so this implies, doubling, yeah, let's put this in here. Doubling the I implies that you're going to twice the force of B. Okay, and if I double the force of B, what's going to happen to the force on the wire? You get twice the force on B. Cool? So you double the amount of push if you double the current that's in there. Now, what happens is the distance in the wires between these two is doubled. Well, that affects this one, how the field is next to a wire that's exerting, carrying charge. And if you're doubling this, that means I've got 1/2, or 1/2 of that is going to happen. So doubling the R implies that you're going to half the amount of B, the field. And if you half the amount of B here, that means this guy's going to be half as much as well. You're going to half the force. So that one was tricky enough because it comes with proportional reasoning. I just wanted to be able to work that out with you. The rest, I think, should be straightforward, and you should be able to get if you just see the answers. Thanks.